Welcome everybody to My Physical World. Today is a beautiful spring day, or should I say, it's a beautiful spring day in the northern hemisphere where I live. For my friends down under, it's probably a beautiful autumn day. Maybe. Well, that's what this episode is all about. It's the very basics of my physical world. It's the basics of Earth-Sun relationships. We talk about why is it becoming summer in the northern hemisphere and becoming winter in the southern hemisphere. From most of my examples that you're going to be seeing, I'm giving it from the perspective of the northern hemisphere for ease of understanding. But everything is the opposite from the north when you talk about the south. So I don't want to discriminate from my friends down under, but just know that from the perspective of the northern hemisphere, it's the opposite in the southern hemisphere throughout the year. So we got some pretty interesting graphics to show you, some animations to show you that will explain the Earth-Sun relationships and how our seasons happen here on this globe. We're also going to be talking about a few other things, such as how we get this spherical world on flat maps. Pretty basic stuff. We're not going to get into the real details of map projections. I will save that for another time when I do a series on cartography, in which I was a cartographer for many years. So, welcome to my physical world, and I hope that you enjoy Earth-Sun relationships. Locations on the Earth's surface are measured by latitude and longitude. Latitude are measurements of the angle from the center of the Earth to the Earth's surface, from 0 degrees to 90 degrees, either in the north direction or in the south direction. Longitude are lines that measure east and west, and they range from 0 degrees to 180 degrees, east or west. Lines of latitude are also known as parallels. They run parallel to one another and parallel with the equator. Lines of longitude, known as meridians, run from the North Pole to the South Pole, and they converge at the poles. Let's say we wanted to find the coordinate 40 degrees north latitude and 100 degrees west longitude. This animation shows how that is found on a globe. The point at which these two planes intersect on the Earth's surface defines its latitude and longitude point. The 40 degrees from the center of the Earth and the 100 degrees is from the prime meridian that runs through the United Kingdom. Getting a spherical object on a flat piece of paper is called a map projection. It's like having a glass globe, turning on a light, and projecting those lines onto a piece of paper. First, we take a plain piece of paper, a planar, and we project those lines on a flat piece of paper. This is good for making maps of the polar regions of the world. Then we take a cone and we place that over our globe, turn on our light, trace the lines, and we get what is called a conic projection. And these are useful for making maps of areas that are long east and west, such as like states like Tennessee and Kansas. Then we have a cylindrical projection, which is taking a cylinder over our globe, turning it on, tracing the lines, and we get maps that are useful for making navigation maps or mapping areas that are tall north and south. The Earth's tilt and rotation. The Earth is tilted on its axis. The reference to this tilt is the plane of the ecliptic, which is also the orbital plane of the Earth around the Sun, and also the Sun's equatorial plane. But the measurement of tilt is based off of the perpendicular to this plane, and that is 23.5 degrees, or 23 degrees, 27 minutes. This tilt always faces the same fixed point in space. That is why we have a North Star, or Polaris. Our north axis always points toward, relatively speaking, the North Star. You could also say that the Earth is 66.5 degrees off the plane of the ecliptic. Now the 23.5 degrees and the 66.5 degrees, that will come into play when we start talking about the Earth and Sun relationship. The rotation of the Earth on its axis, looking down on the North Pole, is counterclockwise, or we would also say it's an eastward rotation. The Earth's annual cycle, its slightly elliptical orbit around the Sun, approximately 365 days. The tilt of the Earth's axis is the primary force behind the seasons throughout the year. This, in relationship to the North Pole, basically always facing in the same direction. Throughout the year, the sun's rays are perpendicular to different locations on the Earth, such as here in the summer, it's 23.5 degrees north. And as the Earth goes into autumn, the sun's rays are perpendicular to the equator. Let's switch perspectives to a top-down. Notice that the Arctic Circle changes from being an all light to all dark. Now we come to our seasons. It's winter in the north. Arctic Circle experiences 24 hours of darkness. A few weeks later, the Earth passes perihelion, which is its closest approach to the Sun, approximately 91.5 million miles. Then comes spring, in which everywhere on the globe shares equal day and night of 12 hours each. We approach our summer solstice in the north in June. The Arctic Circle experiences 24 hours of light. A few weeks later, we reach aphelion, which is our furthest point from the Sun, about 94.8 million miles. Then we come to fall, in which we experience 12 hours of day and 12 hours of night again. Remember when we talked about the 23.5 degrees? Well, this example shows that in the summer, it's 23.5 degrees north latitude, and in our winter in the northern hemisphere, it's 23.5 degrees south latitude that the sun's rays are perpendicular. And the 66.5 degrees? Well, in the north in the winter, anything above 66.5 degrees north latitude is 24-hour darkness, total opposite in the south. Next we come to the equinox, in which the sun's rays are perpendicular to the equator. And when we say the sun's rays being perpendicular to any point on the Earth's surface, that point is known as the subsolar point. So during the equinoxes, That subsolar point is at 0 degrees latitude, which is the equator. In the summer or the winter, it's either 23.5 degrees north or 23.5 degrees south. And then finally, we come to time. The Earth spins 360 degrees in 24 hours. That means that the Earth spins 15 degrees every hour. Here is a time zone map, and each zone is 15 degrees wide. It's hard to talk about time without talking about longitude. Lines of longitude are really an expression of time. Latitude was relatively easy to figure out in the ancient world because they took the angular measurements of the pole star, or Polaris, to the horizon, and that gave them their latitude. Also, 1 degree latitude is equal to about 69 miles everywhere on the globe, traveling north and south. However, longitude is different. It is not based on an angular measurement. It is based on the Earth's rotation, a reflection of time, and was not practical until the invention of the portable timepieces, such as a clock. It's a unique history, longitude is, but we won't get into that right now. Things to know about longitude and time and the rotation of the Earth. There are 180 degrees of longitude, both east and west, centered on Greenwich, England, which gives us a total of 360 degrees around the globe. At the equator, 1 degree of longitude is about 69 miles, 69.172 to be exact, or pretty close. That means the sun rises at a point on the globe approximately 4 minutes before a point 69 miles to the west. However, that rate changes as you move poleward, since the lines of longitude converge toward the poles. For example, at 42 degrees north latitude, 1 degree longitude is 50.705 miles. So the sun rises at a point on the surface approximately 4 minutes before a point 50.7 miles to the west. To calculate your 1 degree distance at your specific latitude, I will put up the formula to calculate that. It's pretty easy. Check it out. Try it. Have fun. Well, I hope you liked today's episode. We learned a few things. We learned about latitude and longitude, how locations on the Earth are mapped based on latitude and longitude. We also learned about the basic map projections, the plane, the cone, and the cylinder, and how we get a spherical object on a flat piece of paper. It's done a little bit different now that we have computers, but you get the basic information about map projections. We also talked about the Earth's rotation on its axis, how it's tilted, how long it takes to rotate. And then finally, we looked at the Earth's revolution around the sun, or its orbit around the sun, and how that controls our seasons throughout the year based on its tilt. We also touched on time, about the rotation of the Earth and how long that takes, and what significant time zones are throughout the Earth. Next time, we're going to be talking about the incoming solar radiation from the sun and the Earth's internal radiation of emitting heat from the Earth. And I hope that you join us next time on My Physical World.